time for some distance formula action. Woo! Love me some distance formula. Okay, so distance formula is actually very closely related with Pythagorean theorem. Our distance formula is x2 minus x1 squared plus y2 minus y1 squared, all inside of our square root. Okay? That'd be our distance. Distance. You can't really read that at all. There we go. Distance. Cool. So let's try it. Say we got an ordered pair. Let's say we have our two ordered pairs. So 3, 7, and -4, 2. Okay? Now, distance formula is going to be more of a pure math type of thing rather than something that's really applicable in our construction side of the stuff, but it is something we do need to cover. So, and I will be honest about those types of things, children. You know, honesty is key. Okay, let's plot these so we can see about where they are on our xy coordinate. So -4, 2 would be 1, 2, 3, 4, 1, 2, something over here. And then we have 3, 7. So 1, 2, 3 in the x direction, 3, 4, 5, 6, 7, somewhere up here. So we're trying to find the distance between these two points, right? Okay, well, we can use our formula to do so. So if I plug that in, just plug and chug, our x's, so you subtract them, -4 minus 3, and then our y's, 2 minus 7, well, that would be, it's here, -7 squared is 49, plus, let's see, we got 2 minus 7 is -5 squared is 25. Okay, so then we have 49 plus our 25, and we end up getting 74. Cool. Well, can we simplify this at all? We can tie in our simplifying of radicals right now. Let's see here. Is 74 divisible by 4? No, because that's a perfect square. How about 9? Nope. How about 16? I'm just working up my perfect squares. Nope. 25 is not going to happen because it's not divisible by 5. Let's see. How about 36? Nope. All right. And beyond that, we're already too big to divide 74 nicely. So this is our final answer. Okay? It cannot be factored down and simplified at all. We could get a decimal approximation for square root of 74. That would be about 8.6, so roughly 8.6. Cool. I just got that by plugging it into my calculator. All right. There's a couple things I want to talk about now. We said that this is somewhat related to our Pythagorean theorem. Why is that? Well, I'm trying to find this length right here, right? Okay. Now, if I were to move horizontally from one point to the next and be right at the same spot, like right above it, and then I were to move vertically right down, I have just created a right triangle. Now this horizontal distance is 7. This vertical distance is 5. 5 squared plus 7 squared, 25 and 49, got those bad boys right there. And then square root of that. So really we just did Pythagorean theorem. 7 squared plus 5 squared equals c squared. That is an equals, not a z. Look at that. Square root it and solve just like we did Pythagorean theorem. So you can actually think about it same way, which is pretty dope in my opinion. Cool. America. Freedom. Rock and roll. Alright, we're going to do some triangle classification here now. It is super fun. Alrighty, so a right triangle. I think a lot of these you guys might be familiar with. So a right triangle just has a right angle. Okay, remember that box notates a right angle. So right triangle. Okay. Next one. Obtuse. 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 Triangle. What the heck does that look like? Ooh. Okay. So, I think right now it's best to talk about how a triangle, and we might have already talked about this, a triangle has 180 degrees in it, right? 180 degrees in a triangle. So when we're classifying a triangle, we're really talking about its largest angle. A right triangle's largest angle is a right angle. An obtuse has an angle that is greater than 180 degrees. Of course, the other two angles are going to be small because it adds up to 180. So you can't have another angle that's bigger than 180 or bigger than 90 degrees in a triangle. Only one of them can be. So that's called obtuse. And then we've got acute triangles are basically what I've been drawing. It's where all of the angles are smaller than 90 degrees. So it could look like that. It could be kind of like this, right? As long as they're all under 90 degrees. Okay, like you could see the one down in the bottom right hand corner of the guy that I just drew. It's like just under 90 degrees. Okay, just under. So there's those three triangles, right? Obtuse and acute, and you'll be asked to classify at times. Given a certain triangle. Okay, what kind of triangle is it, right? Obtuse or acute. Next, we've got based on the sides. So these were all based on the angles, right? All these guys on the left of that line were based on the angles. Now we're going to do based on the sides. Okay, so a scalene triangle has all different side lengths. Okay? So we got three different side lengths. None of these are congruent. Note those tick marks. They're all three are different. That's a scalene triangle. Okay? Isosceles. Isosceles. That's fun. Okay, isosceles is where you have two sides congruent. So it could look like this, where these guys are congruent. Side note, if the two sides are congruent, ooh, them angles congruent too? Heck yeah. Alright, or it could be, rather obtuse. Look at that, bringing back some new vocab words. And the same would, and I'm going to do two tick marks, the same would still apply here. These angles are going to be congruent as well, okay? Cool. Last one, equilateral. Equilateral. Sorry, the writing can be kind of sloppy on this thing, guys. It's tough to write. I'm writing with my finger. Okay? Alrighty, equilateral. All the sides are congruent. And, if you are thinking ahead here, yes, all of the angles, let's see if I can get them in there, all the angles are congruent as well. That's pretty dope. Okay. Alright, a couple more vocab words for you and we're done. Complementary and supplementary. Okay, you've referenced these before, I'm sure, and you probably heard them even in your algebra class. So complementary, comp. I'll often shorten it up to comp because I don't got time to say the whole thing. Come on now. Means they add to 90 degrees. Alrighty, and supplementary, sup brah, add to 180 degrees. Alright, these are present all over the place in construction, so much so that I just don't have time to get to it in this video. You'll see it when we're framing up roofs. Okay, we'll do a little roof truss action. You'll see comp and sup. Okay, those are pretty awesome. All over the place. Alright, so we'll get to that as it comes. But from a vocabulary standpoint, complementary and supplementary, well, comp means that two angles add to 90. Sup, two angles add to 180. Now you know what's up.